So my name is Albrow. I'm an astronomer, a lecturer in astronomy here at the University of Canterbury, and I've been here as a lecturer about 10 years now. Before that I was actually a student at the University of Canterbury. I did my undergraduate degree and my PhD degrees both here, and following that I went away and was a postdoctoral fellow at the South African Astronomical Observatory, which is in Cape Town in South Africa. Then I came back to New Zealand for a while, and then I went to the United States and worked at the Space Telescope Science Institute, where we run the Hubble Space Telescope. And then I got this job back here, and I've been here at Canterbury ever since. Most of what I work on these days is gravitational microlensing, which is a method for detecting planets around other stars in our galaxy. So up until about 15 years ago, the only planets that astronomers knew about were the ones in our own solar system. And since that time we've discovered there's maybe about 700 or 800 planets now known in our galaxy that are associated with other stars. The particular types of planets that I can find through my research are planets that are very, very distant from their host stars. So they're out at about the distance of Neptune. It'd be like in the outer solar system if you were to compare it to our solar system. And that's interesting because most other methods by which all the planets have been found, they're very sensitive to planets that are very close in, like perhaps at the distance of Mercury from the Sun. And that sort of skews or biases the type of planets that they can find. Now we know that most of the planets, when they form, they're actually formed out in the outer parts of solar systems, out beyond where we call the snow line, which is out in our solar system would be sort of between Mars and Jupiter. It's out the part of the solar system where it's cold enough that gases like water exist as solids rather than as gases or liquids, and that allows small particles to clump together to form planets. Okay, so we think that all planet formation initially happened out in these outer reaches of solar systems, and so and then by various gravitational interactions, the planets can migrate inwards. So by studying planets around other stars out in their outermost parts, we're getting clues to the formation of planets. Okay, well I've always been interested in astronomy. Back when I was a child I'd read books about science and about astronomy, and it always fascinated me, the world out there. And I guess I came up through the school system and through university studying physics, and astrophysics is part of physics, so I got that knowledge as I went through. And when it came time to go into research, I decided astronomy or astrophysics was the part of science I like doing and I wanted to learn more about and work on. So I've been doing that ever since. You know, it just excites me that here on Earth we can learn things about the distant stars and galaxies. I like working in this field of microlensing because it allows me to have a huge range of experiences. I can be involved right from the point of going to the telescope and staying up all night and capturing the images and taking the measurements, right through to the finished product at the other end of doing the analysis and extracting the measurements. The other thing is that we get to work in large teams. I get to collaborate with lots of people at different countries and can go and visit them and exchange data and emails every day. So it's a good feeling I get working as part of a team, and I like the successes that we gain through learning about stars and planets and galaxies. I mean, as I said a while ago, we didn't know anything about planets outside our solar system 15 years ago, but one of the major results that we've come from our work is that we now know that almost every star, we can deduce that almost every star in the galaxy probably has planets associated with it. So I've participated in detecting about 7 or 8 published microlensing planets now, but there are more papers that are in preparation. So in fact the number of planets discovered by microlensing is increasing year by year. In fact, it's somewhat surprising I stuck in the field so long, because it took us about 10 years to find the first one from when we started this work.